Welcome to the MicroStation 2025 Onboarding Guide. In this guide, we will be building the pedestrian bridge shown in the image. Step 1 is installation. We have to run the setup MicroStation file to start the installation process. After the initializing setup, you will have the opportunity to read and accept the end-user agreement. There are configure settings, but we will not be making any changes to them. Click Install and give the app permission to make changes to your device. Once installed, you can decide whether or not you want to launch MicroStation when you click Finish. You may have the option to log in to your ProjectWise account if you have one. Step 2 is creating the WorkSet. This is the screen that will appear when you first open MicroStation 2025. Here you can create and select both workspaces and worksets. Workspaces are organizational groups of individual worksets, while worksets typically correspond to an individual project within the group. For this demo, we will be selecting Example as our workspace. You will see that there are already 2 existing worksets, but we are going to create a new one. We will type in pedestrian bridge for the name and a brief description of what this project is. The folders and files will fill in automatically with their default paths and values as defined by the workspace template, so we will leave them as is. Once we are finished creating the workset, we have the option to browse files and create new ones. Since this is a new workset, we will have to create a new file. Step 3 is setting the work environment. After selecting New File, we will type in Pedestrian Bridge as our file name and check that it is saved as a DGN. Then we will click Browse to select our seed file. The seed file is the template for the new file, and all the options shown are included in installation. We will select 3D Metric Design and click Open and Save. Once our file opens, go to File, Settings, File, and Design File Settings. Here we can make sure our working units are in meters to match our seed file. Optionally, you can click View Attributes and turn off the grid if you would like. Next, we will open the Level Manager to organize the information. Make sure the symbology is by level, and then create a new level named Stone Post. Select 166 for the color and 1 for line thickness. Repeat the same process to create levels named Post, Railing, and Walkway. These are the elements that will ultimately make up our bridge. For the walkway level, select 9 for the color and 1 for line thickness. Lastly, we will create a level titled Bridge Path and select 3 for its line style. You can now view all our new levels in the drop-down. Next, we will open the Template drop-down and click Manage. Here we can define all properties for each element. Create a new template group titled Pedestrian Bridge. Then create a new template for Stone Post and pair it with the Stone Post level we have already created. The settings for this template will now match those of the Stone Post level. As you can see, it is possible to add more detailed settings here, but we will not be doing that now. Repeat this process with the other 4 levels we created. You can now see the templates we created in the Template drop-down. Step 4 is geolocating the project. To geolocate the project, we have to switch to the Geospatial Context workflow. Once we have switched, we will select the Coordinate System tool and select the From Library button. Here you can search for coordinate systems or select from library. We will be selecting from the library. Click on Library, Projected, North America, United States, Florida, and then select FL 83/2011E. Once selected, you can view information on the given coordinate system. We can add the selected coordinate system as a favorite to use in another file if needed. Finally, click OK to apply the geographic coordinate system to active model. Next, we are going to toggle our Google 2D background. We can select the Google Maps icon from the ribbon or from Control View to apply a road or satellite background map. Choose Road for map type. Then click inside the border of View 1 to apply the background. After the background is applied, we are going to go back to File and select Close. Once we are back on the home page, we are going to change our WorkSet to River Bridge and click Browse. We are then going to select the bridge master file and open it. You can take a second to try out some of the view tools to change your perspective to display where we'll be creating our pedestrian bridge. Now, we are going to click the previous view group button in the bottom left of the screen and click Open without changing anything. This will take us back to our view from the pedestrian bridge WorkSet. Now, we will go to Attach Tools, select References, and click the Attach New Reference button in order to add the bridge master file. Once you have the master file selected, make sure the attachment method is set to Geographic Reprojected and click Open and OK. Select the Fit View tool and click on any of the non-active views to apply the tool. Now, we are going to do the same process as earlier to change the Google background. Click the Google Maps icon, select Satellite, and click on View 1. You can change the background map for all of the views using the same process. Make sure you capture the indicated region within your View 1 window where pedestrian bridge will be created. Lastly, we are going to go back to Attach Tools and select References again and turn Display off for the master bridge reference file. Then, go to the View tab and click on Create Saved View. Type in a name and click in View 1 to save. This will allow you to return to this area at any moment if needed. Step 5 is Parametric Modeling. The first thing we want to do is to set the views to our desired settings. Make sure View 1's background map is satellite and set the style to wireframe. Then use the Window Zoom tool to zoom in on the pedestrian bridge's location. We are going to use the same settings for View 2 except with a top-down perspective. Optionally, you may drag your Active Tool window to pin it on the right side of the screen. After setting these, we are going to switch to the modeling workflow. Next, select the Bridge Path template, which will activate the properties we previously defined. Now, we can begin to create the bridge. Select the Place Line tool and click a starting point for the bridge on the left side of the waterway. Using AccuDraw, move the cursor right and hit Enter to lock on the X-axis. Type in 24 in the X window to set the length. Left-click or Data to place line and right-click to finish. In View 3, click Fit to View. Select the Place Line tool and snap to the midpoint of the line and move the cursor up. Lock on the Y-axis and type 2 in the bottom Y window to set the height and click Data to place and right-click to finish. Now, we will select the Place Arc tool. Set the method to Start, End, Mid. Then select the left end of the horizontal line, the right end of the line, and finally, the top of the vertical line we made. We have now finished one side of the bridge. You can click Fit View to see the whole bridge in each window. Next, we will create our walkway. Select the walkway template. Navigate to the Place Block tool and select it. In the Tool window, create a new variable for Edge 1 and put in the value 2 for the walkway's width. Repeat this process for Edge 2 with a value of 0.2 for the walkway's height. Select the far left point of the side of the bridge to place the walkway and hit the S key to rotate the cad-design plane to side orientation. Left-click or data point to place block. Now we will move to the Solids tab and select the Extrude Along tool. In the Tool window, make sure Custom Profile is selected. Then select Show for Path so that we can use it in following steps. Then select the path, then block and click Data to confirm. We have now created our walkway. Go back to the Home tab and select the Stone Post template. We will now create the stone posts for our bridge. Zoom in on the left edge of the walkway. Now we are going to go back to the Solids tab and select the Slab tool. In the Tool window, we are going to create a new variable for the width and set it at 0.3. We are going to set this same variable for the length. Then we will create a new variable for the height and set it equal to 1.5. Then we are going to click on the bottom corner of the walkway to place our first post. Hit the T key to rotate the cad-design plane to top orientation. Move your cursor to the left and up to make sure the post is oriented correctly, then click to place. Select Fit View to get the entire bridge back into frame. To quickly place the rest of the 4 corner posts on the walkway, we are going to go back to the Home tab. Now, select the Array tool. Make sure Rectangular is selected for Method. The associative feature allows you to use variables for each setting, so we will check this box. This time, to create a new variable, we are going to go to the Constraints tab and select the Variables tool. Click on Local Variables, and you can see the variables we have already created. Now select Create New Variable and add a name for the variable. This variable will be the space between the 2 posts on this side of the water. So we will make the expression width of walkway minus width of post. Test the expression, then hit OK. The active value should be 1.7 meters. Once you are finished, go back to the Array tool window and make sure the rows and columns are set to 2 each for each corner of the walkway. Then use the new variable for row spacing, and we will use 24.3 for column spacing, since that is the length of the walkway plus the length of the post. Select the corner post, and a left click should place a column at each corner of the walkway. We are now finished with the stone posts. The next step is going back to the Home tab and selecting the railing template. We are going to change the view to right isometric and zoom in on the 2 posts on the left side of the walkway. we are going to select the Place Block tool. Put in 1 for both Edge 1 and Edge 2. Select the front bottom corner of the walkway. Then, with cad-draw active, hit the O key to place the origin at this point. Hit the S key to rotate the plane. Enter 0.1 into the X box and 0.3 into the Y box. Clicking will now place the box in this new location in the center of the post. Now right-click and hold to bring up the pop-up menu and select Copy. Click on the far left point of the bridge path arc and place the copy on the outside bottom corner of the box we just created. Next, we will go back to the Solids tab and select Extrude Along. We will hide the path for this extrusion. First, select the edge we just copied, and then click the box to extrude. Click again to accept. Now we will go back to the Home tab and select the Array tool again. With the method still set to rectangular, we will create a new variable in row spacing for the height of the railing and set it to 1. For column spacing, we will use the space railing variable we already created. Click the existing railing and then click again to accept the selection. You should now be able to see 4 total railings. Next, we are going to create our final element, the posts. Select the post template. Go to the Solids tab and select the Cylinder tool. Create a new variable for the radius equal to 0.02. Then set the height to that of the other railing using the railing height variable we already created. Hover over the midpoint of the top edge of the box and hit the O key to set the cad-draw origin. Then, type 0.5 into the Y value and drag down to place the center point in the middle of the box. Define the axis vertically and left-click to place the post. Now we are going to hold right-click to open up the pop-up menu and select the Copy tool. Select the post we just made, type in 1.7 into the X box, and click to place the post. Now we are going to go back to the right-click menu and select the Copy tool again. This time we will select the path along the bottom of the walkway. Copy this to the center point by snapping to the first post that we just made. Now return to the Home tab and select the Array tool. Select Along Path for method and both for mode. Also, ensure that the associative box is checked. Create a new variable for copies set to 30. Then, create a new variable for distance set to 0.5. Next, click the midpoint of the first post. The end of the path, and then anywhere on the screen to accept. You will now see posts on one set of railings. Now, go back to the Array tool and repeat this process with the opposite first post. Note that the railings do not span the whole bridge. We will fix this later. We are now going to change the visualization. You can use the selections in the video or look through and choose your own. After this step, we are going to navigate back to the Constraints tab and select Variables. Here you can see all the variables we have created throughout this process. Select the corner post height variable and change the active value to 2. Note how changing the active value will update the model in real time. Change it back to 1.5. Next, switch the post copies variable to 50. And you will see that they now span the full length of the bridge. Then for the space between posts, set it to 0.3 meters. You will see that once again, the posts don't cover the whole bridge. Now go to the walkway width variable and set the active value to 3. You will see that only the walkway changed in the model. This is where constraints come in. Switch the active value back to 2. Still in the Constraints tab, select the Fix 3D constraint and zoom in on where the corner post meets the walkway. Select the corner post and the point where they meet to activate the constraint. Next, select the 3D dimension constraint and select the corner post and meeting point again, and then the edge of the walkway. Click the constraint icon and make sure the value is 0. Switch the display back to wireframe for our last constraint. Using the same constraint as last time, select the top of the first close railing and the opposite first railing and select the railing space as the distance. Return to normal visualization and change the active value of the walkway width to 3. You will see that everything expands with the walkway regardless of the active value. Go to the View Attributes tool and turn off markers, so only the model itself is visible. To finish cleaning up the model, we are going to return to the Home tab and open Level Display. As you can see, we can toggle each level here. Turn the bridge path level off. After this is complete, save. Lastly, we are going to create 2 variations of the bridge. In the variables window, select Variations and hit Create New. Name it Wide Bridge. Create another variation named Narrow Bridge. With the Wide Bridge variation selected, change the walkway width to 3. The post radius to 0.03. The post copies to 120, and the post spacing to 0.2. Next, select the narrow bridge and change walkway height to 0.1. Railing height to 0.8. And post spacing to 0.5. Apply each variation to see the updated model for each. Step 6 is adding properties. Now we are going to navigate back to the drawing workflow. From here, select the Attach tab and then open the Item Types menu. Now, create a new Item Types library and name it Pedestrian Bridge. Next, create an item type in the library named Post and then create a new property definition for it. Name it ID and make sure the type is text. Create another property definition for post named Radius and make the type number and the units distance working units. To get the real value from the element, we can create an expression. Open the expression builder. Select this for the function group and then get element. In the right-hand search bar, select base radius. Test the expression to make sure it is valid and then click OK. Create a third property definition named height, and again select number for type and distance working units. Open the expression builder back up and select this and get element again. This time we will select height from the right-hand search bar and click OK. Now we will create our final property definition for post name material. After you name it, open the pick list manager. Click Add New and type in material to create a set. Next, under values we will add aluminum, concrete, steel, stone, and wood. Click Save and Close. Now go back to the material item type and select text for type. Then select DG and files for picklist source and select the material picklist we made for settings. Now go back to the pedestrian bridge library and create a new item type named stone posts. Select the ID and material property definitions from under post and click copy. Then paste them into stone post. Under stone post we will add a new property definition named width. Select number for type and distance working units. Then change the default value to 0.3 meters to reflect the width of the stone posts we created. Add another property definition named height and select the same properties as you did for width. The only difference is we will set the default value to 1.5. We will create another property definition for stone post named area. And once again select number for type. This time we will select the meters squared working unit under area. Open the expression builder and select this and get element as we have before. Select surface area from the right-hand search menu. Select OK. Our last property definition for this item type will be volume. Select number for type, and we will select meters cubed working units under volume. Open the expression builder and select this and get element. Select volume in the right-hand search bar and click OK. Using the arrows in the toolbar, you can move properties up and down. Move material to the bottom of the list. Go back to pedestrian bridge and create a new item type named railing. Copy ID, area, volume, and material properties from stone post and paste them into railing. Then make a copy of the railing item type in the pedestrian bridge library. Right-click on it and select Rename to change its name to Walkway. Select Pedestrian Bridge again and click the Save icon to save the item types library. Close the item types window as well as View 2 and View 3. Make View 1 full screen and fit to view. Next, we will select Attach Item. Note the area and volume values are gray as they will be taken from the element. Click the drop-down arrow, select Walkway and type in W1 next to ID. Next, select Concrete for the material and select the walkway element in View 1 to attach item. Go back to the Attach Item window, deselect Walkway and select Stone Post. Before proceeding, open up the Properties drop-down and turn on Associative Array under Markers. You will see the array icon now appears next to the 4 stone posts. Now go back and type in the given ID. Note that the width and height are the values we already entered with default defined values. Set the material to stone. Now we can turn the markers back off and select the stone post to attach. Now deselect stone post and select railing. Type in the given ID and select stone for material. Click on the railing to attach. Now repeat this process with post and set the material to wood. Rotate the view so that you can select the leftmost post. We will have to put in both the ID and material again in order to select the next set of posts since we made 2 arrays. Select the other leftmost post and close the Attach Item window. Return to the original view. Open the right-click menu, click Element Selection and select the walkway. Right-click on the walkway and open Properties. Select the Items drop-down and click Walkway. You will see the assigned ID and material, and that area and volume are filled. We will repeat this process with the railing. Now open up the properties for the stone post. From the Properties dialog, you can modify the item type properties. Change the ID on the closest post to SP1 and the one next to it to SP2. The other properties will be the same. Finally, we will click one of the posts to view its properties and then close the Properties window. Now, switch to the Home tab and select the Explorer tool. Here you can view both the different item types and arrays. Note that clicking on an item type will highlight it in the model. Select the Stone Post dropdown, and you can select specific stone posts to highlight and zoom in on them as well. Select the Isolate tool to make only the highlighted element visible. Now, return to the normal view and right-click on Stone Posts and select Details to see all information. From here, you can change the properties too. Change the ID of each post so that they are numbered 1 through 4. Now open the details for the post item type. Note that there are 98 rows in the table corresponding to 98 individual posts. Go to the Constraints tab and click Variables. Activate the Wide Bridge variation and go back to the post details. Note that there are now 242 rows, as this bridge variation has more poles than the other variation. You may now close all tool windows. Step 7 is creating a drawing. Open the Level Manager and create a new level. Name this level drawing. Next, select this as the active level and switch to a front view. Save settings. Still in the drawing workflow, navigate to the Annotate tab and select the Plan Callout tool. Use Plan Metric as the drawing seed and make sure Create Drawing is enabled. To place the callout, place the first point at the left side of the bridge, the second point on the right, and click a data point to define the depth. In the Create Drawing window, make the name plan Pedestrian Bridge and check that Create Drawing Model and Create Sheet Model are checked. Make sure Sheets is set to New and Text is full size. Change the detail scale to 150 and uncheck the Open Model box. Click OK. You can now see the callout in the design. Now, switch to the View tab and open the Saved Views window. You will see the callout we just created here. A plan callout is placed in the design model for future manipulation. In the Home tab, select Models. A new drawing model called Plan Pedestrian Bridge has been created. Note that this drawing model is an intermediate model between the design and sheet model. Open References and notice the 3D design model from Pedestrian Bridge is attached in full scale 1:1. A sheet model has been created too, with the drawing model referenced at the selected detail scale 150. Next, we are going to attach a border as a reference. This is an optional step. It is important to note that the border used here is a sample and is not provided. Go back to New Reference and select the border DGN. Make sure the attachment method is Coincident World and click Open. A border will now appear on the sheet. Once completed, go back to the first bridge reference and move it so it is oriented at the top of the sheet. Note the label that includes information on the reference, such as name and detail scale. Placing the mouse pointer in the markers, you can access the pop-up window that contains some options. From here, you can jump to the drawing or design model. Now, go back to the Plan Callout window and open the design model. Rotate back to a front view. Expand the window of the callout so that the entire walkway is inside. All information is connected. Now go back to the callout pop-up window and open the drawing model. Note that it has updated to include the entire walkway to account for the changes we made to the callout window. Open the sheet model from the pop-up window, and you will see that the changes are reflected here as well. Return to the drawing model. Switch to the Annotate tab and select the Section Callout tool to create a section. Select Section Metric Sheet only as the drawing seed and make sure Height is from View and Create Drawing is checked. Create a callout defining the first point at the left side of the bridge and second point on the right, roughly cutting the length of the bridge in half. Click Data to define height. In the Create Drawing window, name the callout Section Pedestrian Bridge. Make sure Create Sheet Model is checked and select our existing sheet model for sheets so it is added to it. Set the detail scale to 150. Check Open Model and hit OK. With the sheet file back open, go to the Home tab and open the References window. Select the reference we just created and select Move. Using the AccuDraw Set Origin tool, move the reference so it is lined up and placed below the one above it. Once it is placed, right-click on the same reference in the window and select Presentation from the pop-up window. Change the forward and cut clip volume settings to From View, and change the display style to Filled Hidden Line. This will change the presentation of the reference in the sheet model. Minimize the window, Fit to View, and open View 2. In the View tab, tile the views so that each takes up half the screen. Fit both to view. Open the Properties drop-down in View 1 and select 3D Metric Design for models. Next, select View 1 with a left click on the top of the view. Go to the Constraints tabs and click Variables. Here we can view the two variations we previously made. Select the narrow bridge and activate it. Note that the sheet instantly updates to reflect the new model. Next, repeat this process with the wide bridge. Close View 1 so that only the sheet model is open and fit to view. Now you have the option to disable markers by deselecting Markers from the Presentation drop-down. Bring up the right-click menu, select Level Off, and click one of the markers to make them not visible. Save settings. Step 8 is Reporting. Before starting, we will review and modify the item types. Switch to the Attach tab and open the Item Types menu. Open the drop-down for both post and railing. Select Volume and Area from under Railing and click Copy. Then click on Post and Paste. Move area and volume above material using the arrows to change the order. Now click the Pedestrian Bridge library and save. Close the window. Return to the Home tab. We are going to open the Explorer dialog in order to view all the items we have created. Clicking each item will highlight it in the model. Right-click on Railing and select Details. Here you can view a table with information for the 4 individual railings. Change the material to wood. Now open the details for post and note that the additional dimensions we pasted are in the table. Now we are ready to create reports. We will navigate to the Analyze tab, select Reports. Create a new folder named Pedestrian Bridge. We will create 2 reports, one for a specific element and another to create the bill of material for the bridge. For the specific element, we will create a report definition for stone post as our example. For search location, select the Model 3D Metric Design. Open the Selected Objects window. Select Stone Post and click OK. Open the drop-down for Stone Post and click Columns and add columns. Click both the drop-downs for stone posts and checkmark each column option. Select OK to close the window and then preview the stone post report. You will see that each of the columns we selected is now added. Create a new report definition in the folder for the bill of material titled BOM Pedestrian Bridge. This will include information on all of the item types. For search location, select the Model 3D Metric Design again and open the Selected Objects window. Select all 4 item types. Open the Add Related Object drop-down and select Item is attached to Element. Element is on level. and levels. This will allow us to add the element type in our table. Next, we will go to Columns and select Add Columns. Remember, ID, area, volume, and material are common for all item types. Open the drop-downs for common item type properties and check all 4 properties. Then select Name under the General and Levels drop-down. If you need to, you can add other properties for other item types. Click OK to add. Once again, using the arrows, move Name to the top of the column list. Then, click to rename it as Element Type. Now when we preview the report, the table will reflect the custom order and column headers, and any row will show information for each separate element. Close the preview window and select Groups and Aggregates. These will allow us to organize the data. Click Add Group and select Element Type and save. Under Aggregates, hit the plus button to add a rule. Select ID and Count. In the preview, you will now see the count of each element under ID. Close this window and click Summarize. Hit the green plus to add a rule, and once again select ID and Count. Then, add Area and Sum. And lastly, Volume and Sum. Click Preview and we can now see the total area and volume of the elements that we added it for. Now, go back to the Reports window. You can export the table to Excel or place as a table. We will be placing as a table. Open up the Sheet Model view as this will be the destination of our table. Select Place as Table. In the Place Table window, we will open Text Style. Here you can alter the text. However, we will be leaving all these settings the same. After this is completed, we will click to place the table on the sheet. Once placed, you can configure settings for the table. Click the top row of the table and select the Fill tool and select 9. Then select the Totals row and repeat the fill process with the same color. Double-click the top row to open the text editor where you can make the text bold. Click the Borders tools and select All. Reopen the tool and select Outside this time. Change the line thickness to 2. You will see all our changes reflected in the table. Step 9 is Visualization. Change your display style to wireframe. Note that the display only shows edges and surfaces of the solids. Now open Level Manager. Right-click in the Details row to ensure that Materials is selected. Now we are going to apply a material to each feature. For Walkway, select the Concrete and Pavers palette from the drop-down. Then select Concrete New. For Stone Post, select Stone and Gravel from the palette drop-down. Then select Stone Wall. For Railing, select Wood. And then Flat Pine. And finally for Post, select Flat Pine again. Navigate back to Display Style and select Filled Hidden Line. Then Modeling. Note that the elements are displayed as filled polygons with the element color. Go back to the Display Style drop-down and select Illustration, Default. Now you can see that the polygons are shaded using material dimensions. Next, select Smooth and Modeling. and we will see a smooth shaded image with materials where applied. Lastly, go to Smooth and Shadows. This is the same as the smooth display with shadows included. You can zoom in to get a better view. Now make sure that the model is fit to view. Open the References menu and you will see that the bridge master file we attached earlier is there. Enable Display. Click Fit View, and you will see that both bridges are now included in the view. To obtain a better view to display the information, we will place camera. Switch to the View tab and open View 2 with a top view of the bridge. We will be using the Place Camera tool. But first, we want to make sure that markers are turned off in the Properties menu of View 2. Now, we can click on the Place Camera tool. In the Setup Camera menu, make sure camera height is set to 0 and target height is set to 5 to get an optimal view. Click in View 1 to set as active. Now zoom in on the pedestrian bridge in View 2. Select the upper left post to define the camera position. Zoom back out and click near the far right end of the larger bridge to define the target point. View 1 will now show the camera view. From here, you can move and rotate to get the desired view. The Save Settings button will save various settings in the DG and file, such as the current view. Once you are satisfied with the view, go back to the Home tab and open the References menu again. This time we are going to attach a new reference. Click the Attach New Reference icon. These references will enhance the scene. Select WorkSets from the drop-down. Then select River Bridge, DGN, and then the Buildings and Structures file, and the Vegetation file. Make sure the attachment method is geographic reprojected and click Open. Click OK on any alert windows. You can now close the References window. You will see that the view now includes various buildings and plants. Go to the Adjust View Brightness tool and click Default Lighting. Then, click the Background Map drop-down and change the display plane to the design plane. With these two changes, no underground structures are visible and the lighting is improved. Now, open the File tab. Go to Settings, File, Design File Settings, click Views, Background, and click the three dots. Select the Material Preview background and click Open and OK. Go back to the model. Check that background is turned on in the Properties menu and note the new attached background. Now, obtain your desired view to make a render of. We have chosen this as our view to make our rendering. Switch to the visualization workflow. In the Rendering section of the ribbon, select Render Scene. In the View Rendering window, open the Light Manager. Select the morning setup and click on Solar and then Solar Position. Click on Date and select today's date at the bottom. Then, use the arrows to make the time 11:30. Lastly, click the city icon and select Miami, where our project is located. Close the window. With ray tracing selected, change the light setup to morning. Atmosphere to Cirrus Sunset, and quality to Exterior Good. Then click Render to render the active view. When the render is complete, you will see the final rendering with the chosen settings. With the completion of the render, the onboarding guide will be finished. Thank you for watching.